Hello and good day, everyone. Today we're going to talk about basic knowledge about black holes and a bit of introduction. So now we have to define what is the black hole. A black hole is an object with an extremely strong gravitational pull that is because it's so dense that nothing, even light, can escape from its surface. That's why it looks black and can absorb anything. Uh, So here we have the history of the black hole. First, it was used as a prediction on the mathematical solution to Einstein's equation. And then the black hole solution was found by Karl Schwarzschild in 1915, which will be talked about later. The next is, after 1 year, Albert Einstein was the first one to predict the existence of the black holes. And this helps to complement his theory about the general relativity. Before we know the black hole, we need to know the definition of the escape velocity. So escape velocity is the speed of an object that must obtain to break free from the gravitational attraction of another body. So here are the two things about how it can affect the escape velocity. The first is density of the object. The more dense it is, the larger the velocity will be. And the second one is the distance to the center of the body, of the object. So the closer it is to the center, and the larger the velocity will be. This will be demonstrated in the later slide. And now we have this equation about the relationship between the escape velocity and the mass of the body and the distance from the center to the mass. And then we have the universal gravitational constant to connect the terms. So this is taught in the high school. And then we have Schwarzschild radius. The Schwarzschild radius is the radius which the mass has an escape velocity, which equals to the speed of light. So in other words, we can say that any object that is smaller than this radius is the black hole, because each object with different density will have a unique Schwarzschild radius. So for example, the mass of our sun in our solar system is around 2 times 10 to the power of 30 kg. So for something that the mass of our sun will need to be squeezed into a volume with a radius about 3 kilometers, then it can become a black hole. So here the picture shows the structure of a general black hole. So the two basic parts is the singularity and the event horizon. So the distance between the singularity and the event horizon is the Schwarzschild radius. And the event horizon is the boundary that marks where the escape velocity from the mass is the speed of the light. So how could we detect the black hole? Let's say because we mentioned that nothing, even light, can escape from the black hole. So how could we observe it? So scientists actually determine in an indirect way, like with trying to detect the black hole by detecting the surrounding materials like gas, because the gas is found out by the force of the gravity into the disk around the black hole. Since the movement of the gas could be very fast and heat up, they will emit X-ray, and the X-ray can be detected from the Earth. So now it comes to the types of the black holes. There are majorly three types of the black hole: stellar, supermassive, and the primordial. So it's defined by the mass and the size of the black hole. So the first type is a primordial. Primordial black hole is actually a theory that only that forms in the first second after the birth of our universe. In a moment, like a lot of hot materials may have been dense enough to form a black hole. So there could be a lot of black holes, primordial, but with very small volume. But the universe quickly expanded and cooled. So the condition of the black holes like this type is ending very fast. Most of them just gone evaporated. So these two pictures show a different theory: the major theory and the primordial theory. So we don't have the definitive proof that the primordial black holes existed. It is possible, and the lower mass black holes could easily and quickly evaporate, and that's the reason why we couldn't find any primordial black holes in our universe present. The next one is a stellar. So this is basically the core of the star, which is more than light times, 8 times of the sun's mass will collapse, rebound, and explode as a supernova. If the mass is going to be bigger, then it will collapse into a stellar mass black hole. Here we have the next one, the supermassive. This is the most largest in our galaxy, including our Milky Way. We all have this kind of supermassive black hole in the center. They may have hundreds of thousands of millions of times of sun's mass, and they could be growing up by feeding on other smaller objects like the small type of black hole and other suns or planets. So this is the one that in the center of our galaxy. This picture was taken in 2022. With this, I end my presentation. Thank you very much for listening.